Hey guys, welcome to my channel. I'm GDcoder. If you guys are new to my channel, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have a pretty interesting problem, so let's go ahead and read the prompt statement, right? So he says, given the root of a boundary tree, right? He says, return the level order traversal of its nodes values from left to right, level by level, right? So they want us to process the nodes level by level, right? And as we're processing the nodes level by level, to put them in a temporal list, right? And then add them to the output list, right? So let's go through an example, right? So you see 3, right? Three's at this level all by itself, right? So that's why it's in a list all by itself, right? 9 and 20 are on the same level, right? That's why they're on the same list, right? 15 and 7 are also on the same level, so that's why you put them on the same list, right? 15 cannot be in the same list as 20 because they're not on the same level. I'm saying the level matters. I'm saying, yeah, so that's why we do that. I'm saying, so level, if they're on the same level, then they correspond to the um, same list, right? Yeah. So now I didn't know the problem. So this is a breadth first search problem, right? This is a very good breadth first search problem, BFS, right? As yeah, so because we need to process the nodes level by level, and in a good algorithm for that, guys, is a breadth first search. I didn't know the problem that used the same kind of approach, the BFS approach that I'm about to use, and then yeah, so you guys should check that out. Something should pop up on there. I guess you should check it out. It's called binary tree right side view. So I kind of used I used the breadth first search on that same problem, so you guys should check that out. All right. So now the way we're gonna go about it, right? We're gonna use a queue, right, to process the nodes level by level at each time, right? We're gonna process the nodes for a particular row. We're gonna have this size variable that's gonna let us know how many nodes are at this particular level that we're at, right? So that's why we're gonna know how many nodes, and then we keep populating the queue with our children, right? And then we go on to the next level. So for 3, right? We add 3, so we have a temporal list for every level, right? Temporal list, we add 3 to a temporal list, right? And then, right, after we're done processing all the nodes for that level, we add that temporal list to the output list, right? Which is gonna hold a list of lists, right? So this is a list, right? Right there, and then it's gonna hold a lot of lists inside of it, right? So after we process a particular level, right, we add that temporal list that it's gonna help us, right, to the um, output list that we're trying to create, right? So that's kind of how the algorithm is going to work, guys. So let's go ahead and implement it, right? So now we're going to do a check, right? If the root is null, right? So we check if root is equal to null to return a new empty, all right? Empty list, right? I'm saying if it's definitely be processed, we're not going to waste your time checking anything. I'm saying we're in the clear. So now that we need to do some stuff, right? So we're gonna use a queue like I promised, right? A queue, very important, and a breadth first search. I'm saying there's gonna be a queue of tree nodes, right? Queue, and then we're gonna use the linked list implementation of that, right? And then now we're gonna have to have our output list that we're creating, right? That's the output list. So we call it res, right? And that's what we're gonna return, right? So now, guys, the next thing that we're gonna do, right? We're going to have this while loop, right? This is standard when you're doing breadth first search, guys. So this is very first similar in every problem that uses breadth first search. I'm saying, so while the queue is not empty, right, while there's still nodes to be processed, guys, we're gonna stay inside that while loop. I'm saying, so now, like I told you guys, right, we take the size of that level, right? So we're gonna call it level size, right? We take the size of that level, right? So we take the way we're gonna do that is by taking the current size of it, right? So now, guys, one important thing that we need to do, right? We need to make sure that we add the root to the queue, right? Because if we don't add it in there, we're never gonna enter this while loop, right? Because so we need to add the root so that we can start processing the nodes as intended, right? So now we take the size of that queue, right? So once we take it, guys, we also gonna initialize our temporal list that we're gonna have, right, for that particular um, level that we're at, right? So now it's gonna be a list of integers, right? And there's gonna be, so let's call it level list, right? So level list, right? That's gonna hold all the nodes values, right, for that particular level. I'm saying. So now that we do that, right, we're in pretty good shape. So now we're gonna have this for loop, right? And this is where the I is gonna come into play, right? I mean, the size is gonna come into play, guys. Well, I is less than the size, right? So now we're gonna, yeah, I plus plus, right? So pretty much this for loop pretty much gonna help us to iterate through all the nodes for that particular level. I'm saying because we're gonna keep populating the queue as we go, and then the level size variable that we have, right? So so the for loop, right, that we have right here, right, it's gonna help us. We're gonna iterate through all the nodes that's at this particular level. I'm saying so the level size variable took a snapshot of the level size at this particular time, right? We do that, guys, because we're gonna keep adding stuff to the queue. You know what I'm saying, because we don't want to process nodes that don't belong to a particular level, and that's why we are able to keep track of the level size. Before we start processing any nodes at a level, we take a snapshot of the size first, and then we start processing the nodes. I'm saying, so we know what we're able to do that, right? So now, guys, the next thing that we're gonna do, right? We're gonna take the nodes out of the queue one at a time, right? So we take one out, right? And after we do that, guys, we need to add it to. So we take one out, right? So now we're gonna process it, guys. We're gonna do level list, right? We're gonna add it to that list, right? That it corresponds to. So we're gonna add the value of it, right, to the level list, right? We're gonna add its value, right? And after we do that, guys, we have to check, does it have any children, right? So we check, does it have a left child? It does. So we add it. If it does, we add it to the queue, right? So it could be processed. You know what I'm saying. And then we need to check the right. Does it have a right? Does it have a right child, right? If it's not null, right? If I mean there's something there, right? So we would go there, guys. You know what I'm saying. All right. So after we do that, guys, once we loop through all the nodes for that particular level, so now we could add it. We could add the level list, right, for that particular level, right? We just add it to the output list that we're building. You know what I'm saying, so we just add it there, and then we're good, right? And then after we're done, like, so once there's no more nodes to be processed, guys, I think we should be in pretty good shape. So we return the result to the to call this function, right? Yeah, there's an extra an extra bracket. So all right, we were able to pass that test case. Let's check if we pass all the test cases. It's extremely slow. I don't know why, but it's kind of weird. All right, we're able to pass all the test cases, guys. So let's just go through this example really quickly. All right, so pretty much, guys, like I told you guys, right? Well, we have three, right? Three. So we add three to the root, right? To the queue, right? And then we start processing, right? So we take a snapshot of the size, right? We take a level size, boom, we know there's only one for that particular level. So we create a new temporary list, right? So we could add it to the output list that we're building, right? So now we loop through all the nodes for that particular level, this for loop, right? So we know there's one, right? So we take one, so we know there's one. So we take one node at a time, right? So we take three out the queue, right? The queue is empty now. And then we add the value of three to the temporary list that we're creating, right? To let the level list, and then we check the children, right? We check the left first because it says from the left to right, right? And then we add it to the queue, right? If there's a left child, we add it to the queue. If there's a right child, we add it to the queue as well, right? And then we keep doing that, and then once we're done, we process all the nodes for that particular level with the help of this for loop, right? We add it to we added the level list, that the temporary list that we're creating, right? We add it to the output list, right? So now once we do that, 9 and 20 are inside of the queue now, right? Because of this, because we added the children, right? So now we start over again. Now the queue size is going to be 2, right? So we take a snapshot of it, boom, boom. We know there should be only 2 elements for that level, right? We create a new list, right? And then we start over again, right? We process 9. We add 9 to that list that we just created. And we check its children. There's no children, right? Boom. And then we're cool. Now we'll check 20, right? we still in this folder, we still in there because there's still notes to be processed, right? Because we promised them there's 2 elements in there. So that's why we're still in there. So now we're gonna process 20, right? So we take 20 out, and then we add 20 to the temporal list that we're building, right? And then once we're doing that, we check the left and the right, right? We add 15 first, and then we add 7. And then now we are done processing all the nodes for that level. So because I is equal to 2, and then we exit out of this for loop, right? And then, guys, we add that temporal list that we're building. We do the same thing for this level, guys. Yeah. So this is how that works, guys. I'm saying I highly suggest that you guys check out that other video that I did. You'll see the code is very similar, guys. I'm saying it's this algorithm is very nice. So make sure that you guys know the details because there's other problems just like it. Just the constraints are changed and they're just trying to trick you off. But if you understand the underlying concept, you guys are in pretty good shape. So yeah, guys, I want to thank you guys for taking the time to watch this video. If I did a pretty good job, make sure to like this video. Also, if you guys have any questions, let me know in the comment section. And if you guys are new here, make sure to subscribe because I'll do a lot more videos like this, just like this one. And yeah, I want to thank you guys for watching, and I'll see you guys in the next one.